Hi everyone, this is Mary Niba here. In this lecture, we are going to see about binary search algorithm and its implementation using C++. Okay, we'll move on to the topic. First of all, what is searching? So we are well familiar with this word since if each and every day we thirst to search something new, right? Here also, searching means searching a particular element in an array. So, here, what is binary search? We all know that by means 2. So, we divide the entire list stored in the array into two halves. We repeat this until we spot out the target value. An item in a sorted array of length n can be located with just log n comparisons. We'll see the algorithm with a simple example. So here you see we have 12 elements. So the elements are arranged in the array and the 12 elements, among the 12 elements, we have to search the element 70. So the elements are 12, 15, 33, 35, 42, 45, 51, 62, 73, 75, 86 and 98. So what is the first step? First step, we have to divide it into two halves. So for dividing this, we have to find out the middle value. So what is the middle value? We have know the formula. So the middle value is nothing but the first element plus the last element divided by 2. So first we have to designate the first element as the left. So here I have taken three variables, left, right and middle. So left is the first index, right is the last index, that is the 12th element, and middle is nothing but the 6th, that is 12 plus 1 by 2 is 13 by 2. So we can take the 6. And now it's checking whether the middle value is less than the search number. So we have to search the number 70. So the middle number is 45. So whether 45 is less than 70? Yes. So if that is the case, the number will be only in the right half. So we can remove the left half. That's done here. Then again we have to reassign the left, right and the middle because we know that binary search is nothing but repeatedly halving the whole list of elements into 2 until we found out the search element. So that requires log n comparisons. So the left element is now the 6th element, 6th position, that is 45, and the right element is the last element, that is the 12th position element, 98, and the middle element is 6 plus 12 by 2, that is the number 9th position, that's we took it as 73. And now again we compare it whether the middle number is greater than the search number or not. So our middle number is actually 73, which is greater than the search number 70. So we can, so the right position is of no use, so we can ignore it. So now you have only 4 elements. So now we can reassign the left, right and the middle element. So the left element is now the 6th position element, that is 45. Right element is the 9th position element, that is 73. And now 6 plus 9 by 2. So you'll get the middle position you are taking it as 7. You can take it as 7 or 8, no issues. So if you take it as 7, so that is 51, it is less than the search element. The search number is 70, so but the middle number is here, it is 51. So it is less than the search number. So now it is comparing, and if it is less, so we can remove the left half because we know that the element is present only on the right half. So now you'll get only, after removing the left half, you'll have only 3 elements. So we can take the left as 51, that is 7th element, and the right as 9th element, that is 73, and the middle is obviously the 8th element, that is 62. So if we just compare it again, if you search it, if the middle number is less than the search number, middle number is 62, it is less than 70. So we can remove the left half. So the remaining two numbers are 62 and 73. Now it is checking whether R minus L is equal to 1. So the right element minus left element is now equal to 1. 9 minus 8 is equal to 1. So until then the process goes on. So we have continued till now and 70 is not in the list. So it did just display that the number 70 is not in the list. So this is what the algorithm of binary search, that is repeatedly halving the algorithm into 2 and then it just to find out where the number is present. So it takes log n times comparisons. So I'll see with a simple C++ example. It is easy or convenient to see with the compiler. So I'll just take the compiler. So first thing is, as we have seen in the linear search algorithm, the first thing is we have to enter the number of elements in the array. So that I am taking it as C. Then we are taking the elements. So just if you want to get the elements, because the array elements, if you want to get it, we have to include it in a for loop. All this we know, right? Then we have to enter the number which we want to search. Up to this, it is similar to linear search algorithm. Then comes the binary search concept, logic. So here we have to declare some first element, we have to declare some last element, we have to define some middle element. So just we have defined the first element to be the 0th element. So f equal to 0 and L equal to z minus 1. So if the count is 5, so the last element is, because the array starts from 0, so the last element is, so 5 minus 1 is 4. And the middle is nothing but f plus L by 2. And so we have seen a condition, last condition. So till when it should exist, so your first element should be greater less than the last element, or f minus L is equal to 1. So you are putting it in a while loop. So in the while loop, we are just taking whether f is less than equal to 1. So if that is okay, yeah, if it is less than or equal to 1, so we are just comparing the array elements whether it is less than the number. That is, middle element is less than the search number. So if that is the case, we know that we have to hold the left off. So we are just taking the first element to be middle plus 1. So else if, so we have to implement the same logic using if else loop. And finally we have to display the middle plus 1 value. That is, the number is present in middle plus 1. So in some cases, if the number is not present, as we have seen in the example, if f is greater than L, so it has to display the number is not in the array. So this is a simple logic. The program, the logic we have seen lot of simple examples. So using this, we are using while loop and if loop, if else loop. So we have to implement it because we have a condition, that is our f minus L should be greater than or equal to 1. If it is f minus L is 1, it should halt the division. So or it should stop dividing. So that condition should be checked. So here what is happening means in the logic, so we are just putting a while loop. So our condition is our f is less than or equal to L. In that case, first it is checking whether our middle number is less than the number. So if it is, our number is 70, our middle number is 52, means yes, it is less. So if it is less means the left half is not going to do nothing. So we have to ignore the left half. How to ignore the left half? We can easily tell in the concept, but how to ignore the program? We have to reassign the f equal to 0, that is the first element, to the element middle plus 1. Else if it is not less, we have to ignore the right half. And we have to just tell the number is found in the, so if it is equal, so we have to check that also. If it is equal to the number, we have to tell that it is present in the middle plus 1 value, because we know that the array starts from 0. So to give the exact position, we are taking m plus 1. Else, so we have to reassign the left, because we have to ignore the right position. So left is equal to m minus 1. So this is the very important logic. And what is m? M is f plus L by 2 again. So if f is greater than L, so it should display the no element in the array. So in this way, so the binary search algorithm proceeds, And the logic is very simple. So we have to just divide the whole list of elements in the array into two, and then we have to compare it with the middle element. So we have to assign first element, last element and the middle element. Then we have to compare the middle element, and if the search element is equal to the middle element, then we can display it, or otherwise if it is less we have to ignore the right half, and otherwise if it is greater we have to ignore the left half. So this is the simplest logic, and searching algorithms are always simple to understand. So this is the logic. So the program is also listed in the PPT. Okay, thank you for watching this video. Thank you.